Okay, now we're just going to find the sum of finite and infinite geometric series, sequences or series are infinite. Example 3 are all finite. So I'm going to start off with the finite geometric sequence. Okay, this formula only works when it's set up like this, where it starts from I equals 1, it goes to some value n, and the formula is in the format for an that was described on the second page. If it's not in this exact format, you have to adjust the format in order to use the formula, which we will do once or twice. Okay, but let's look at this and then I'll try to match it up to the formula. Okay, so I'm trying to find the sum from 1 to 8. Okay, now if I look at the formula, the first thing it has is an A1. A1 is in front of the R. There is nothing here. Since there's nothing here, it's like an imaginary 1. So A1 is 1. Okay, let me do the little parentheses. In the numerator, it's 1 minus R. R is 4/5. To the N, which is 8, over 1 minus R. Okay, now it does tell me to round to the nearest thousandth, which is very common on these. So you don't have to do this by hand, but you do need to know how to put it in your calculator properly. Okay, so when you put it in your calculator, depending on your calculator, when you do 1 minus 4/5, make sure the eighth is applying to the 4/5, the entire 4/5, but only the 4/5. Okay, and then that entire quantity gets divided by 1 minus 4/5. And for your answer, you should get something like 4.161. If you are not getting that answer, you're going to play with your calculator so that you can figure out how to input it to give you this answer. Okay, we're going to try B. B is very similar, but the formatting of it doesn't quite match what I want it to match, so I'm going to have to make adjustments in order to make it work. Okay, so for B, I want to find the sum from 0 to 11. It's 5 times 2 to the n. I know it's geometric because it looks like it's geometric. It's something times r to the, well, normally it's n minus 1, but this is n. Okay. In order to apply this formula, it has to go from 1 to some value n. Right now, I'm going from 0 to 11. So I'm going to have to make an adjustment to this. So I'm going to try to rewrite this. Okay, I want it to start at 1. So I'm going to rewrite this formula so it's equivalent, but so it starts at 1. Okay, normally it starts at 1. No, normally starts at 0 and it goes to 11. So if I go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, I actually am going 12 terms. So now I want it to start at 1 and go up to 12. Or because I move this up 1, I'm moving this up 1. Okay, now I have to fix the formula to make this match. So I'm going to keep the 5. I'm going to keep the 2. But I wanted to plug 0 in first. That's what the formula told me to do. So I need to put something here that makes it equivalent to 0 here when I plug in a 1. So I'm going to put n minus 1. And then we're going to stare at this and make sure that it actually matches the original summation formula I saw. So this was n equals 0, which would give me 5 times 2 to the 0. If I start with 1 and I plug in 1 here, 1 minus 1 is 0, so it's still 5 times 2 to the 0. So I'm still starting with the same term. Okay, when I finish, I plug in 11, which would make this 5 times 2 to the 11th. When I finish, I plug in 12. 12 minus 1 is 11. So this is still 5 times 2 to the 11. The only reason I rearranged it is so that I could then use this finite geometric sequence formula. And yes, I will give that to you on the test. Okay. Okay, now that it's in the correct format, I can use the formula. So A1 is the 5. 1 minus R is 2. N is 12 over 1 minus 2. Okay, and then you're going to very, very careful put that in your calculator. Watch your parentheses. You might have to do the numerator and the denominator separately and write it on this, write it and then figure it out. But you should get 20,475. If you wanted to check, you could add up all 12 terms and make sure it does in fact equal to what it's supposed to equal to. Okay, let's use the formula one more time because I'm trying to show you what we do when we don't have all the information we need. Okay, so let me look at this sequence. They told me it's geometric, but if I was just staring at it, does it? It does divide by, no, it divides by -2, divides by -2, divides by -2. So upon inspection, since I'm dividing by -2, my r is -1/2, which I need for the formula because they didn't give me the formula at all. Okay, so let me set up what I have, and then I will figure out how to evaluate the rest. Okay, so let's see. I want to sum from I equals 1 to, I don't even know what I'm summing up to because they didn't tell me how many terms there are. Okay, do I have the first term? I do have the first term. It's -10. R is -1/2 because I just looked at it and figured it out. And I can make this I -1. You can also make it an N if N makes you happier. Doesn't matter to me, it's the same formula. Okay, so I actually have most of the information I need, but I don't know what N is, or in this case, what I is. Okay, so I need to figure out which term this is right here. So I'm going to set this formula up and I'm going to solve for N. Okay, so the formula for this thing is -10 times -1/2 to the N minus 1. Okay, and I want to figure out which term 5/64 is. So what N value is 5/64? Okay, and I'm going to try to solve this thing. I don't know if I left enough space. Okay, let me divide or multiply by -10. -1 to the N minus 1 equals 5/64 times -1/10. I'm going to cross cancel. If I cancel by 5, that goes down to a 2. Okay, so -1/2 to the N minus 1 equals -1/65 into 128. Okay, let me try to rewrite this using this same base from chapter 3. -1/2 to the, this should be a 128. 2, 4, 8, 16, 32, 64, 128. So 128 is the 7th power. Okay, now that they have the same base, it must be true by the 1-to-1 property that n minus 1 is equal to 7, so n equals 8. So now after all that work, I'm going to put an 8 here, and then I'm going to use the formula. Okay, to use the formula, okay, it says A1, 1 minus r, put your r in parentheses, to the n over 1 minus r in parentheses. Okay, and again, you're going to be so careful with your parentheses on this thing. Put it in your calculator. I got -6.641, and it told me to round to the nearest thousandth, so I'm okay with this. If you're off using your calculator, make sure you have parentheses around your -1/2 before you raise it to the 8th, because it's going to turn it to a positive. Make sure you have parentheses around the numerator, and then divide it by the denominator. Keep playing with your parentheses until you figure out what the mistake is. Okay, last example is going to be finding the infinite sum. Okay, this is the formula for infinite sum. The setup for infinite sum is from 0 to infinity. So if it's not set up from 0 to infinity, I will make an adjustment to make it 0 to infinity so that I can apply this formula. Okay, if it's set up like this, then it's just the first term over 1 minus r. Okay, the one restriction on this thing is the absolute value of r has to be less than 1. Okay, the reason that is true is just imagine if r was 2. If you keep multiplying by 2 and multiplying by 2 forever, your numbers are getting bigger and bigger, so you're going to approach infinity. So it's never going to converge to an answer, which is why your r has to be less than 1, or the absolute value of r has to be less than 1, so that it doesn't keep increasing infinitely. Okay, let me go down to example 4, and we'll try this. Okay, let's see. It's supposed to be set up as a1 r to the n. And it is supposed to go from 0 to infinity, which it does, so I can work with it. Okay, there's no a1 listed here, so we assume a1 is 1. Okay, according to the formula, since I'm all set up, it's a1 over 1 minus r. Okay, and if you look at the directions, it does not say to round to the nearest whatever. And that's because these normally come out nicely. Okay, let me do a common denominator. 5/5 minus 2/5, 1 over 3/5, which gives me 5/3. And your work here could be different, but we should get 5/3, and I'm not going to round it. Okay, for b, it's also an infinite sum. Okay, so let me consider what I need. I need the first term and I need the r. I have the first term. The first term is the 5. Okay, I need to figure out what the r is, and I can just do that by inspection, by looking at it. Okay, so if I go from 5 to 1, I'm dividing by 5, so r must be 1/5. Okay, so if I want to find the summation of this sequence, it would be the first term divided by 1 minus r. Okay, should I show you another method for solving this? You could do it like the last one, or you could, this is another way, I could times 5 on the top and bottom. Don't do more ways if you have a way that works though. That would be 25 over 5 minus 1, 25 over 4. Okay, that's my final answer. And no, your work didn't have to look like that, but your setup should have looked like that. Okay, last one. Okay, C is an infinite sum. It's going from 0 to infinity. This looks like a geometric series. It has a1 times r to the n. Okay, so I want to find the sum of it. Okay, now there's a problem with this one. Okay, if I look at this one, the r was 1/5. If I look at this one, the r was 2/5. If I look at this one right here, r is 3. Okay, but the absolute value of r has to be less than 1. So this is going to be undefined because the absolute value of r is not less than 1.